Hello and welcome back to the Sleepy Facts. I am so glad you are here with me tonight. Before we begin our journey into the quiet world of science, I want you to take a moment to just be here. Put away the worries of the day. Let the noise of the world fade into the background. Tonight, we are not going anywhere fast. We are staying right here, getting comfortable, and letting our minds drift into a state of peaceful curiosity. If you can, adjust your pillow. Pull the covers up just a little bit. Let your jaw unclench and your eyes rest gently in their sockets. There is nothing left to solve tonight, no decisions to make. Tonight, we are going to explore the silent, steady world of natural minerals. These are the quiet building blocks of our planet. They are the bones of the earth, resting deep beneath the soil, holding stories that span millions and even billions of years. While we often think of rocks as dull or static, the world of minerals is filled with hidden order, slow motion, and astonishing patience. As we wander through these facts, allow the rhythm of the words to slow your breathing. Let the images form softly in your mind. There is no test at the end. Just a gentle journey into the deep, slow earth. Let's begin. Our planet is built from a library of ingredients, and we call these ingredients minerals. A mineral is not just a piece of rock. It is a specific chemical recipe, a substance that nature makes following strict rules. Each mineral has a specific chemical composition, meaning it is made of the same ingredients every time, and a specific crystalline structure, meaning those ingredients are arranged in the same pattern every time. This order is what makes mineralogy so soothing to study. In a world of chaos, minerals follow rules. They obey the laws of physics with perfect consistency. When atoms come together to form a mineral, they are not rushing. They are finding the most stable, comfortable arrangement possible. It is a process of settling into place, like a tired traveler finally sitting down in a quiet chair. Knowing that this order exists deep underground, repeating itself perfectly for eons, brings a sense of stability to the mind. Let's start with the most familiar mineral of all, the one that sits on your dinner table. Halite, which we know as salt. It is a simple mineral made of sodium and chlorine. But its simplicity is its beauty. If you were to shrink down to the size of an atom and walk through a crystal of halite, you would see a perfect city of cubes. The atoms stacked together in a rigid, box-like grid that extends in all directions. This is why, when you look at a grain of table salt under a microscope, you often see tiny, perfect cubes. The mineral is not trying to be a cube. It simply cannot help it. Its internal nature forces it to express itself as a square. Halite forms when ancient seas evaporate. Imagine a shallow lagoon under a hot sun. The water slowly retreats, leaving the salt behind. It is a quiet ending to a body of water, a transformation from liquid chaos to solid order. When you taste salt, you are tasting a mineral that dissolved in the ocean, was compressed into stone, and now dissolves again on your tongue. It is a cycle as old as the earth, quiet and essential. Beneath our feet, in the dark, cool places of the world, lies the most common mineral group in the Earth's crust, feldspar. You have likely walked on it thousands of times without knowing it. It makes up more than half of the rock on the surface of our planet. The name feldspar comes from German words meaning field stone, because it was so often found in the soil of fields. It is a quiet, humble mineral, rarely flashy, but it holds the continents together. Feldspar is born from the cooling of magma deep underground. As the hot liquid rock slowly loses its heat, atoms begin to link hands and form crystals. It is a slow dance of chemistry. Because the earth cools slowly, these crystals have time to grow large and distinct. They lock in potassium, sodium, and calcium, acting as a time capsule for the chemistry of the deep earth. When we see the white or pink grains in a piece of granite, we are seeing the slow, steady heartbeat of the planet solidifying over millions of years. There is a comfort in knowing that the ground we stand on is made of billions of tiny crystals, each one formed in silence, resting patiently in the dark. Quartz is perhaps the most famous mineral, a name that echoes in jewelry shops and science classrooms alike. But its true beauty lies in its resilience. Quartz is tough. It does not weather easily. While other minerals dissolve in rain or crumble under pressure, quartz endures. This is why most of the sand on our beaches is made of quartz. Imagine a mountain range rising, weathering under the wind and rain, and slowly crumbling into grains. The other minerals wash away or turn to clay, but the grains of quartz survive. They tumble down rivers, are swept into the ocean, and are washed up on shores to become beaches. So, when you walk on a sandy beach, you are walking on the enduring remains of ancient mountains. You are feeling the history of the earth beneath your bare feet. Quartz is made of silicon and oxygen, the two most abundant elements in the crust. It forms in a beautiful hexagonal prism, a six-sided shape that points to the geometric rules governing its growth. Inside a geode, those quiet rock spheres that look so ordinary on the outside, quartz grows into sparkling points that line the hollow cavity. It grows layer by layer, atom by atom, in the dark. It waits for no audience. It grows simply because the conditions are right, creating beauty in total isolation. Then there is mica, a mineral that behaves like a book. Mica forms in thin, flat sheets that peel apart almost effortlessly. If you have ever seen glittery specks in a sidewalk or a rock, you have likely seen mica. Its most striking feature is its perfect cleavage. Cleavage, in mineralogy, is the way a crystal breaks along flat planes. In mica, the bonds between the sheets of atoms are incredibly weak, while the bonds within the sheets are strong. This means you can peel off layers as thin as paper, transparent enough to see through. In the past, before we had glass, large sheets of transparent mica were used as windows for furnaces and even for early houses. It was called isinglass. Imagine a cabin in the cold woods, with windows made of mineral sheets, glowing with the light of the fire inside. Mica reminds us that the earth can be flexible, that hardness is not the only strength. It grows in cooling magma, and as the surrounding rock shifts, the mica sheets align themselves, creating a shimmering effect in rocks like schist. It catches the light, turning a dull stone into a glittering pavement, a quiet surprise hidden in the rock. Deep in the limestone caves, away from the sun, calcite is at work. Calcite is the main ingredient in limestone and marble. It is a mineral of transformation and foundation. The shells of ancient marine organisms are made of calcite. When those creatures died millions of years ago, their shells accumulated on the ocean floor, compacting into thick layers of limestone. This means that much of the Earth's crust is built from the skeletons of ancient life. It is a humbling thought. The white cliffs of Dover, the great pyramids of Egypt, the marble statues of antiquity, all are made from the recycled remains of tiny sea creatures. Calcite is also the artist of the underground. In caves, water drips through the limestone, dissolving a tiny bit of calcite along the way. When that water reaches an open cavern, it deposits that mineral drop by drop. Over time, these drops build stalactites hanging from the ceiling and stalagmites rising from the floor. It is a process of extreme patience. A stalactite grows only a fraction of an inch in a human lifetime. It is a slow, steady accumulation, a monument to the power of consistency. In these dark, quiet caves, calcite builds cathedrals of stone, never rushing, never pausing. One of the most soothing concepts in mineralogy is the idea of the Mohs scale of hardness. It is a simple, orderly list that ranks minerals by how easily they can be scratched. At the very bottom of the list is talc. Talc is the softest mineral. It is so soft that you can scratch it with your fingernail. It feels like soap or wax, smooth and greasy to the touch. Talc is made of tiny sheets that slide over one another, which is why it feels so slippery. We use it in baby powder and makeup, a mineral that touches the most sensitive skin. It forms when other minerals are changed by heat and pressure, a process called metamorphism. It is a mineral of gentleness. In a world of hard edges and sharp corners, talc is softness personified. At the other end of the scale is diamond, the hardest natural material. But let us stay with the softness for a moment. Talc reminds us that minerals are not always cold and jagged. They can be smooth, soothing, and yielding. When we powder a baby with talc, we are using the softest rock on earth to protect and comfort. It is a beautiful intersection of geology and tenderness. We must also consider the mineral kaolinite. It is a humble clay mineral, white and powdery. It forms when feldspar, that common mineral we discussed earlier, weathers away over long ages. It is the primary ingredient in porcelain, the fine ceramic used for delicate cups and plates. Imagine a quiet teacup, thin and translucent. It began as a hard crystal in a mountain, was broken down by rain and wind into soft white clay, and was then reshaped by fire. Kaolinite is also used in paper, paint, and even some medicines. It is a mineral of refinement. It hides in plain sight, covering the pages of glossy magazines and the walls of our homes in the form of paint. Its structure is tiny plates, stacked like loose leaves. When wet, it becomes plastic and moldable, holding whatever shape we give it. When fired, it becomes hard and white. It is a transformation of earth into art, of mud into fine china. The quiet journey of kaolinite from mountain rock to teacup is a testament to the patience of nature and the slow alchemy of the earth. Iron oxides are the minerals that paint the world in reds, yellows, and browns. Hematite is one of the most common. It is an ore of iron, heavy and cool to the touch. But its most soothing gift is its color. When crushed, hematite produces a red powder. For tens of thousands of years, humans have used this powder as a pigment. We call it ochre. Our earliest ancestors used hematite to paint the walls of caves, to create the handprints and the running animals that still survive in the dark of Lascaux and Altamira. When you see the red soil of a desert or the rusty color of a canyon, you are seeing hematite. It is the rust of the planet. Oxygen reacting with iron, slowly turning the earth into a canvas of warm colors. There is something deeply grounding about this. The same mineral that runs in our blood, giving it the red color, is the mineral that paints the cliffs and canyons. Hematite connects us to the earth in a very visceral way. We carry this mineral inside us. It reminds us that we are made of the same stuff as the planet, that our biology is built from the chemistry of the rocks. It is a connection that spans the distance between the internal and the external, the living and the mineral. We should also consider gypsum, a mineral of water and light. Gypsum is a sulfate mineral, and it is remarkably soft, just above talc on the hardness scale. It forms when salty water evaporates. In dry lake beds and desert flats, gypsum crystallizes in beautiful shapes. One variety is called selenite, named after the Greek word for moon, Selene. Selenite is transparent and clear, catching light in a way that looks like captured moonbeams. It forms in long, blade-like crystals. In the Nica mine in Mexico, conditions were perfect for gypsum to grow to an unimaginable size. There, in a hot, humid cavern, crystals of selenite grew as big as tree trunks, some of them over 30 feet long. It is a silent cathedral of crystal, a place where geology has frozen time. Gypsum is also the mineral of home. When we build walls, we use drywall, which is essentially a sandwich of paper and gypsum. This soft, white mineral surrounds us in our houses, creating the quiet boundaries of our rooms. It absorbs sound, slows the spread of fire, and provides a smooth surface for our lives. From the moon-like blades in a dark cave to the silent walls around your bed, gypsum is a quiet guardian, a mineral of protection and stillness. Finally, for this part of our journey, let us look at the mineral that gives us the deepest sense of time. Zircon. It is not a famous gemstone, but to a geologist, it is the most precious thing on Earth. Zircon is incredibly tough. It survives when the rocks around it melt or crumble. Because it is so durable. It holds the oldest records of our planet's history. Inside a grain of sand, there might be a tiny zircon crystal that formed over 4 billion years ago, when the Earth was just a cooling ball of fire. Scientists use zircon to date the Earth, reading the radioactive clocks inside the crystal lattice. It is a tiny time capsule. Zircon reminds us of the immense scale of time. It has witnessed the formation of the continents, the rise and fall of ancient oceans, and the long evolution of life, all while sitting quietly in the rock. It does not demand attention. It simply endures. To think of zircon is to step outside of our own brief lives and look at the long, slow history of the planet. It is a perspective that can quiet the anxious mind. We are part of a story that is much longer, much older, and much more patient than we usually imagine. The Earth is steady, and its minerals are the keepers of its memory. As we pause here, consider the ground beneath you. It is not just dirt. It is a library of minerals, each one with a story of formation, pressure, and time. They are the quiet foundation of everything. They do not rush. They do not worry. They simply exist, holding the structure of the world together. Let this thought settle your mind. You are resting on a foundation that has been here for billions of years. It can hold you up. You are safe. We have so much more to explore, so many more quiet stories to tell. But for now, just breathe. Let us drift deeper now, moving from the common stones that build our world to the rarer, quieter treasures that form in the dark. We have spoken of structure and patience. Now let us speak of light and color. The earth is an artist, and minerals are its paints. But this art is not created with brushes. It is created with chemistry, heat, and immense time. As we explore these next facts, allow your mind to visualize the colors. Imagine the deep greens, the ocean blues, and the fiery reds. These are not just colors on a surface. They are stories trapped inside a crystal lattice, waiting for light to unlock them. Let the images form slowly, like a photograph developing in a darkroom. Consider the sapphire and the ruby. They are the mineral aristocracy, prized for centuries for their beauty. But scientifically, they are siblings. They are both varieties of the mineral corundum. Corundum is simple in its recipe, just aluminum and oxygen, but it is incredibly hard. It is the scratch-proof glass on a luxury watch, the sandpaper that smooths wood. It is a mineral of work and utility. But when nature adds a tiny, almost invisible secret ingredient, it becomes a gem. A few atoms of chromium slip into the crystal structure, and the stone turns a deep, blood red. We call this a ruby. A few atoms of iron and titanium slide into place, and the stone turns a velvety blue. We call this a sapphire. It is a humbling thought. The difference between a tool for grinding and a crown jewel is just a few atoms. It reminds us that small changes, applied with patience, can transform something ordinary into something magnificent. These stones form in metamorphic rocks, deep within the earth where continents collide and pressure reshapes the land. They grow in silence, under the weight of mountain ranges, waiting for the slow erosion of the earth to bring them to the surface. Emeralds carry the color of the deep forest. They belong to the beryl family. Beryl is a hexagonal crystal, growing in long, six-sided pillars that look like they were carved by a geometrician. While pure beryl is clear like glass, the emerald gets its green from trace amounts of chromium or vanadium. But emeralds are famous for something else: their inclusions. While we often think of flaws as mistakes, in emeralds, they are poetry. These internal cracks and fissures are often called jardin, the French word for garden. Under a microscope, an emerald looks like a dense, tangled garden of vines and branches. These inclusions are proof of the stone's turbulent birth. Emeralds form in conditions of intense stress and shifting rock. They carry the scars of their creation, and yet, they are stunningly beautiful. There is a lesson in that. Perfection is not the only form of beauty. The cracks and gardens inside an emerald tell a story of survival. They make each stone unique, a fingerprint of the earth. When you look at an emerald, you are not seeing a flawless piece of glass. You are seeing a survivor, a crystal that grew despite the chaos around it. Let us turn our thoughts to opal. Opal is different from the crystals we have discussed. It does not have a rigid, repeating atomic structure. It is amorphous, meaning without shape. Instead, opal is made of millions of tiny, microscopic spheres of silica, all stacked together in a neat grid. Imagine a box of marbles, perfectly arranged. When light hits these tiny spheres, it bends and scatters. It breaks apart into the colors of the rainbow. This is the famous play of color. A flash of red, a wink of blue, a shimmer of green, all moving as you turn the stone. Opal is a mineral that acts like a prism. It is also a mineral of water. Opal contains a significant amount of water, sometimes up to 20%. It forms in the cracks of rocks where silica-rich water settles and slowly evaporates. In the dry, arid regions of Australia, the world's opal capital, this process has been happening for millions of years. Opal is a mineral that remembers the water it came from. It is soft and needs protection, but it offers a display of light that no other mineral can match. It is a captured sunset, a solidified rainbow, a quiet reminder that nature plays with light as well as any painter. Then there is turquoise, the color of the sky on a clear morning. Turquoise is a phosphate mineral, often found in arid regions where copper-rich groundwater seeps through rock. T is a stone of the desert. Its color comes from copper, the same element that gives the Statue of Liberty its green hue. But in turquoise, it creates a range of blues and greens that have captivated humanity for thousands of years. From the burial masks of ancient Egypt to the jewelry of the Native American Southwest, turquoise has been a symbol of protection and sky. It is a porous stone, absorbing oils from the skin, changing and evolving over time as it is worn. It has a matte, waxy luster, soft and warm, unlike the cold brilliance of a diamond. It feels organic, almost alive. When you hold a piece of turquoise, you are holding a piece of the desert's history, a memory of ancient waters that once flowed through dry ground. It is a calming stone to look at. Its color cools the eyes. It brings the vastness of the sky down to a small, handheld object. Jade is another stone of deep history and profound strength. When we speak of jade, we are usually talking about one of two minerals, jadeite or nephrite. Both are incredibly tough. Note that I say tough, not hard. Hardness is about scratching. Toughness is about breaking. Jade is not the hardest stone, but it is perhaps the toughest. Its microscopic fibers are interlocked like the threads in a rope. This means it does not shatter easily. For Stone Age ancestors, this made jade the perfect material for axes, hammers, and tools. It could withstand impact that would shatter other rocks. Later, it became a stone of royalty and spirit. In China, jade was considered the imperial gem, more valuable than gold or diamonds. It was valued for its subtle luster and its ability to ring like a bell when struck. The concept of the sound of jade is ancient, clear, high, and musical. Jade forms in subduction zones, places where the ocean floor is diving beneath the continents. It is a mineral of the deep earth, born from extreme pressure. Its green color ranges from the palest white to the deepest emerald. It feels cool and smooth to the touch, like polished soap. It is a mineral of endurance, a stone that binds itself together against the odds. Let us consider a mineral that glows. Fluorite is a fascinating crystal that seems to have a light of its own. It comes in a rainbow of colors: purple, green, blue, yellow, and clear, often banded together in a single crystal. But fluorite's hidden magic is a property called fluorescence. This word actually comes from the name of the mineral. If you take a piece of fluorite into a dark room and shine an ultraviolet light on it, it transforms. It glows with an eerie, electric light, often blue or green. It is absorbing the invisible energy of the UV light and releasing it as visible light. It is a silent transformation of energy. This mineral is a favorite for collectors because of its perfect cubic crystals. It forms in perfect cubes, often growing inside one another like Russian nesting dolls. It is a geometric wonder. Fluorite is also an industrial workhorse. It is used as a flux in steelmaking, helping to lower the melting point of the metal. It is a mineral of duality, soft enough to scratch with a knife, yet strong enough to help build skyscrapers. Its glow is a quiet reminder that there is more to the world than what we can see with the naked eye. Hidden energies are everywhere, waiting to be revealed. Peridot is a stone of fire and light. It is the gem-quality variety of the mineral olivine. Olivine is a common mineral in the Earth's mantle, that hot, viscous layer beneath the crust. Peridot is born in fire. It is brought to the surface by volcanoes, carried upward in rising magma. In some rare cases, peridot comes to us from space. Certain meteorites, called pallasites, contain crystals of olivine suspended in iron. Imagine holding a slice of a meteorite in your hand. The green crystals are peridot, set against the metallic background of a broken asteroid core. This is a stone that has traveled the solar system. Its color is a distinctive yellow-green, the color of new leaves in spring. It is one of the few gems that comes in only one color, though the shade can vary. The ancients called it the gem of the sun. They believed it could ward off nightmares and bring happiness. Its history is linked to the island of Zabargat in the Red Sea, a desolate, fog-shrouded place where the stone was mined for thousands of years. Peridot connects us to the volcanoes and the stars. It is a bright, lively presence in the world of minerals, a spark of green fire captured in stone. We must also pay tribute to garnet. While many people think of garnet as simply a dark red stone, it is actually a whole family of minerals. Garnets can be red, orange, green, yellow, and even rare blue. They are nesosilicates, meaning their structure is made of isolated islands of atoms, held together by strong bonds. This makes garnet a robust and durable stone. It is often found in metamorphic rocks, rocks that have been baked and squeezed. Garnet is a thermometer for geologists. The chemistry of the garnet changes as the temperature and pressure change during its growth. By looking at a garnet crystal, a scientist can read the history of the rock it grew in, understanding how hot it was and how deep it was buried. It is a silent witness to the Earth's past. The deep red variety, almandine, was used in the ancient world for jewelry and even as an abrasive for sanding wood. There is something very grounding about garnet. Its color is the color of pomegranate seeds, deep and rich. It does not sparkle with the fire of a diamond, but it glows with a warm, inner light. It is a stone of substance, a mineral that feels heavy and real in the hand. Lapis lazuli is not a single mineral, but a rock composed of several. Its main ingredient is lazurite, which gives it that intense, celestial blue. But it also often contains specks of pyrite, fool's gold, and white calcite. The result is a stone that looks like the night sky, deep blue with golden stars. For thousands of years, lapis was the only source of ultramarine, a brilliant blue pigment. It was more expensive than gold during the Renaissance. Painters reserved it for the robes of the Virgin Mary, as it was considered a holy color. The finest lapis comes from the mountains of Afghanistan, a remote and rugged land. It has been mined there for over 6,000 years. Lapis connects us to the history of art and the history of human devotion. To look at a piece of lapis lazuli is to look at a solidified piece of the night sky. It is a stone of royalty and divinity, a mineral that has traveled the Silk Road and adorned the tombs of pharaohs. Its deep blue is soothing to the eye, a color that suggests depth and silence. Let us touch upon the concept of twins in the mineral world. Sometimes, two crystals grow together, sharing a common structure. These are called twin crystals. They look like mirror images of each other, or like two hearts beating in one body. Staurolite is a famous example. It is a brownish mineral that often forms crosses. These fairy crosses are twin crystals that intersect at perfect 90-degree angles. They have long been considered charms of protection. Then there is the Carlsbad twin in feldspar, where two long crystals penetrate each other. These twins are not errors. They are proof of the symmetry laws that govern the atomic world. Even when the environment is stressful, the crystal finds a way to maintain its order, often by twinning. It is a beautiful metaphor for partnership, two entities growing separately, yet fundamentally connected by a shared internal structure. Finally, in this segment, let us consider the quiet beauty of chalcedony. This is a family of microcrystalline quartz. The crystals are so small you cannot see them with the naked eye. They are fibrous and intergrown. This structure makes the stone feel smooth and waxy. Agate, onyx, and jasper are all types of chalcedony. They form in the cavities of rocks, often layer by layer, like the rings of a tree. Agate, in particular, is a marvel of nature. It fills the hollow spaces in volcanic rocks. As mineral-rich water seeps in, it lays down bands of color. Red, white, blue, brown, the layers follow the shape of the cavity, creating concentric circles of astonishing complexity. Cutting an agate geode open reveals a landscape of color. It is a mineral that grows from the outside in, filling the emptiness with pattern. Agate is a stone of balance. Its banded structure represents the layers of time, the slow accumulation of moments. It feels grounding to hold. It is smooth, hard, and silent. It tells us that even in hollow spaces, beauty can grow. Even in the empty places, nature can create a masterpiece of patience. As we pause our exploration of these colored treasures, take a moment to visualize the spectrum you have just traveled. From the red of ruby to the blue of sapphire, the green of emerald, and the starry blue of lapis. These colors are not accidents. They are the result of light dancing with atoms in the dark. They are the result of millions of years of waiting. Let the thought of these colors settle in your mind. Imagine a gallery of stones, each one glowing quietly in the dark. The earth is a painter, and its palette is endless. Rest with that image for a while. There is no need to rush. The minerals are not going anywhere. They have been here for millions of years, and they will be here for millions more. We will continue our journey soon, but for now, just breathe and let the colors fade softly into the background of your mind. Let us continue our descent into the quiet earth. We have looked at the gems that catch the light and the common stones that build our continents. Now, let us explore the hidden forces and the secret chambers where minerals grow in isolation. Imagine yourself moving through the cool, dark rock, passing through layers of time. The earth above is heavy, but down here, the pressure is not a burden, it is a gentle hug that holds the structure together. In this segment, we will visit the places where water and stone meet, where metals sleep in their rocky beds, and where invisible forces shape the mineral world. Allow your mind to slow down further. There is no need to hold on to these facts tightly. Let them wash over you like a gentle underground stream. One of the most enchanting places in the mineral kingdom is the pegmatite. These are not just rocks, they are nature's treasure chests. Pegmatites form during the very last stages of a magma cooling down. Imagine a pot of soup simmering on the stove. As it cools, most of the ingredients settle out. But the very last bit of liquid is often rich in water and rare elements, the concentrated essence of the melt. This watery fluid is extremely hot and flows easily. It pushes into cracks in the surrounding rock. Because it is so fluid and rich in ingredients, crystals and pegmatites can grow to incredible sizes. We are not talking about grains of sand here. We are talking about crystals the size of telephone poles. Tourmaline crystals that are meters long. Sheets of mica that are yards across. These are the giant crystals of the earth. They grow in a slow, watery soup, unhindered by the crowding that happens in normal magma. It is a thought that expands the mind. Deep underground, there are crystal cathedrals, hidden vaults of giant, perfect geometric forms that no human eye may ever see. They rest in the dark, giants of the deep earth, patient and still. Speaking of tourmaline, this mineral is a marvel of the pegmatite world. It is a complex silicate, meaning its recipe includes a long list of elements: aluminum, iron, magnesium, and many others. This variety gives tourmaline a stunning range of colors. It can be pink, green, blue, black, or even watermelon colored, with a pink center and a green rim. But tourmaline has a secret ability that bridges the gap between the mineral world and the world of energy. It is pyroelectric and piezoelectric. This means that when the crystal is heated or squeezed, it develops an electrical charge. It can actually attract dust or small pieces of ash, like a tiny magnet. In the 18th century, Dutch traders used this property to clean their pipes. They would heat a crystal of tourmaline, and the electric charge would pull the ash out of the meerschaum pipes. They called it the ash puller. It is a charming image, a stone that acts as a cleaner, responding to the gentle presence of warmth or pressure. It reminds us that even in stillness, minerals are active. They are responsive. They hold potential energy, waiting for the right trigger to awaken. When you hold a piece of tourmaline, you are holding a battery made of stone, a quiet reservoir of natural electricity. Let us move into the world of metallic minerals, where the darkness of the deep earth meets the shine of metal. Pyrite, often called fool's gold, is a mineral of perfect geometry. It is iron sulfide, and it forms in the most striking shapes. While gold is usually found as shapeless nuggets, pyrite grows in perfect cubes. It is astonishing to see a pyrite crystal. It looks like a box made by a machine, with sharp corners and flat sides. Yet, it grew naturally atom by atom. This cubic form is a direct reflection of its internal symmetry. The atoms are stacked like dice in a box, and the external shape mirrors that internal order. Pyrite also forms in suns flat, round disks of radiating crystals. It is a mineral that loves structure. It is found in sedimentary rocks, like coal and shale. In the coal mines of history, pyrite was a common sight, sparkling in the lamplight. While it has no monetary value like gold, it has a scientific value. It tells us about the oxygen levels in ancient oceans. Pyrite forms in low oxygen environments, so its presence is a clue to how the Earth breathed millions of years ago. It is a shiny, metallic file folder of Earth history. Its weight feels reassuring in the hand, a solid, cool block of order. But perhaps the most soothing metallic mineral is galena. Galena is the primary ore of lead. It is heavy, surprisingly heavy. When you pick up a piece of galena, it sinks into your palm with a satisfying weight. It is a grounding sensation. Galena has a metallic luster that is bright and shiny when fresh, but it can tarnish to a dull gray. Its most striking feature is its cleavage. If you tap a piece of galena gently, it breaks into perfect cubes. It shatters into small, heavy boxes. This is because the bonds between the atoms are weak in certain directions, allowing the crystal to split perfectly along flat planes. It is a mineral that teaches us about fragility and strength. It is soft and heavy, easily broken, yet it is the source of lead, a metal that protects us from radiation and sound. Galena was also the crystal used in the very first crystal radios. In the early days of radio, a sharp wire, often called a cat's whisker, was touched to a piece of galena. This simple contact could detect radio waves, pulling music and voices out of the thin air. Imagine a dark room in the early 20th century, a family gathered around a headset, listening to a faint signal, all thanks to a heavy, gray stone. Galena connects the mineral world to the world of sound and communication, a silent stone that learned to sing. We must also consider the invisible force of magnetism. Magnetite is a black, heavy mineral that acts as a natural magnet. It is iron oxide similar to hematite, but with a different arrangement of atoms. That difference allows magnetite to hold a magnetic field. If you bring a magnet close to a piece of magnetite, it jumps to meet it. The attraction is physical and undeniable. The ancient Greeks discovered this property in a region called Magnesia, which is where the word magnet comes from. But magnetite's history goes back much further than the Greeks. It is found inside the brains of birds, bees, and even bacteria. These tiny crystals of magnetite act like compass needles, helping animals navigate the Earth's magnetic field. They allow a bird to fly thousands of miles in the dark and still find its way home. It is a profound thought. The same mineral that guides the mountains also guides the migrating swallows. It connects the geology of the planet to the biology of life. There is a famous variety of magnetite called lodestone. A lodestone is a piece of magnetite that has been naturally magnetized by the Earth's magnetic field. It was the first compass. Sailors would float a piece of lodestone on a piece of wood in water, and it would turn to point north. In a world without GPS or maps, this heavy black stone was a lifeline. It was a guide. It reminds us that the Earth is surrounded by an invisible bubble of magnetism, a protective shield that we cannot see, but that the minerals can feel. Let us return to the quiet places where water and stone interact. The zeolites are a family of minerals that form in the bubbles of volcanic rock. When lava cools, gas bubbles are often trapped inside, leaving cavities. Later, water seeps through these rocks, carrying dissolved elements. Inside these cool, watery cavities, zeolites grow. They are delicate, intricate crystals. Some look like tiny, white snowflakes. Others look like delicate needles or puffy cotton balls. The name zeolite comes from the Greek words meaning boiling stone. When zeolites are heated, they release water that was trapped in their structure, appearing to boil. They are microporous, meaning they are full of tiny holes on a molecular level. These holes can trap molecules of gas or liquid. Because of this, zeolites are used in water purification and detergents. They are the sponges of the mineral world. They clean. They filter. They grow in the quiet spaces left by ancient fire. To look at a zeolite specimen is to see a delicate, frozen garden. The crystals often radiate outward in sprays of white or pale green. They are fragile, a reminder that beauty can be delicate and still endure. They occupy the empty spaces, turning a hollow void into a crystal palace. Next, let us consider the oxidized zones of the earth, where the air meets the rock. This is the realm of azurite and malachite. These are copper carbonate minerals. Azurite is a deep, profound blue. It is the color of the midnight sky or the deep ocean. Malachite is a vibrant, swirling green. They are often found together, with green malachite replacing blue azurite over time. It is a transformation of color. These minerals form near the surface, where rainwater mixed with oxygen seeps down into copper deposits. The water acts as a slow alchemist, changing the copper metal into colorful carbonates. Malachite is famous for its botryoidal habit, a term that means it forms in bubbly, grape-like clusters. When you slice a piece of malachite open, you see concentric rings of green, looking like the growth rings of a tree or the eye of a cat. It has been used for thousands of years as a pigment for paint and as a stone of protection. It feels cool and smooth, like polished glass. Azurite, with its intense blue, was used by medieval painters for the robes of angels. But it is unstable. Over centuries, the blue can turn green as it slowly converts to malachite. This teaches us that minerals are not always static. They continue to breathe and change, even after they have been mined. They respond to the air, to the light, to the humidity. They are slowly evolving works of art. We should also appreciate the quiet beauty of moonstone. Moonstone is a variety of feldspar. It does not have the brilliance of a diamond or the color of an emerald. It has a soft, inner glow. This effect is called edgelurescence. Inside the stone, thin layers of two different feldspar minerals are stacked together. When light enters the stone, it scatters between these layers, creating a billowy, ghostly reflection that moves across the surface of the stone as you turn it. It looks like moonlight gliding through a veil of clouds. The Romans believed that moonstone was formed from frozen beams of moonlight. It is a stone of softness. It does not demand attention. It asks you to look closer, to see the subtle interplay of light and structure. It connects us to the night sky, to the ancient rhythms of the tides. Holding a moonstone is like holding a captured moonbeam. It is a soothing presence, a mineral that whispers of gentle nights and silent watches over the sleeping world. Labradorite is another feldspar, but it holds a different mystery. It usually looks like a dark, gray rock, unremarkable and dull. But when you turn it to catch the light, brilliant flashes of color appear. Peacock blue, electric green, gold, and orange. This is called labradorescence. It happens because of internal fractures and layers that interfere with the light. It is a stone of hidden depths. It reminds us that ordinary exteriors can hide extraordinary interiors. It is a mineral of surprise and wonder. It was discovered on the island of Labrador in Canada. An Inuit legend says that the northern lights were once trapped in the rocks of the coast. A warrior found them and struck the rock with his spear, freeing most of the lights into the sky. But some of the light remained trapped in the stone, giving us labradorite. It is a beautiful story. It links the mineral to the celestial dance of the aurora borealis. When you look at the shifting colors in a piece of labradorite, you are seeing a geological echo of the northern lights, a silent fire locked in stone. Let us turn our thoughts to the concept of weight and density. Barite is a mineral known for being heavy. It is a sulfate of barium. It forms beautiful, tabular crystals that look like blades or books. But its defining characteristic is its weight. A small piece of barite feels surprisingly heavy in the hand, much heavier than a similar-sized rock. This high density makes it useful. It is used in medicine. When patients need an X-ray of their stomach or intestines, they drink a barium shake, a thick, white liquid made of crushed barite. Because barite is opaque to X-rays, it shows the digestive tract clearly on the scan. It is a mineral that we consume to see inside ourselves. It is also used in drilling for oil, mixed into mud to control the pressure in the well. It is a workhorse mineral, a heavy, quiet presence that helps us see the invisible and drill the deep. Its weight is a grounding force. It reminds us of the mass of the earth, the density of the matter that makes up our world. We should also speak of celestine. As the name suggests, it is a mineral of the sky. It is a strontium sulfate, and its color is a pale, ethereal blue. It often forms in delicate, translucent crystals that look like shards of frozen sky. It is found inside geodes, where the crystals point inward, creating a sparkling blue cavity. The largest known geode in the world is a celestine geode in Ohio, big enough for people to stand inside. The walls are lined with crystals up to 3 feet long. It is a cathedral of light blue stone. Celestine feels fragile and peaceful. It is the source of strontium, which is used to create the red colors and fireworks. So, celestine holds the potential for celebration. A quiet, blue stone that contains the secret of red fire. It is a mineral of contrast, quiet on the outside, fiery inside. The color blue is known to calm the mind, to slow the heart rate. Looking at the delicate blue of celestine is like taking a deep breath of fresh air. Finally, for this segment, let us consider the concept of the epitaph of the mineral world. Desert roses. These are not flowers, but they look like them. They are made of gypsum or barite, crystallizing in sandy deserts. As the mineral grows, it traps grains of sand into its structure. The crystal blades spread out in a rosette shape, looking exactly like a stone rose. They are rough to the touch, sandy and fragile. They form in arid places where the wind shapes the dunes and the heat bakes the ground. They are the earth's way of blooming in the desert. They remind us that beauty can thrive in the harshest conditions. They are a symbol of endurance and adaptation. A desert rose sits quietly on a shelf, a flower that will never wilt, a memory of the sand and the wind. It is a perfect image to hold in your mind as you drift towards sleep. A stone flower, blooming in the eternal silence of the mineral kingdom, waiting for nothing, simply existing in its beautiful, sandy form. As we finish this segment, think of the vast, hidden world of metals and crystals. The giant pegmatites, the electrical tourmalines, the heavy galena, and the glowing labradorite. They are all parts of a whole, a complex, interconnected system that operates on a timescale we can barely imagine. The earth is solid beneath you. It is composed of these quiet, steady materials. You are supported. You are held. Let the weight of that support settle your body. The deep earth is sleeping. And you are sleeping with it. We have more to explore, but the journey is long and slow. Rest for a moment in the blue glow of celestine, or the sandy embrace of the desert rose. As we settle deeper into this journey, let us shift our gaze from the deep, heavy stones of the earth to the elements that interact with light, life, and time in gentler ways. We have traveled through the fiery birth of gems and the quiet chambers of caves. Now, let us look at the minerals that bridge the gap between the inanimate and the living, and those that carry the essence of purity. Imagine the world slowing down. The sounds of the day are long gone. There is only the steady rhythm of the earth. Let your breathing match that rhythm, slow in, slow out. We are drifting now, floating through a landscape of soft colors and clear water. Let us begin with a mineral that many of us interact with every day, often without realizing it. It is graphite. While we often think of lead in pencils, there is no lead in them. It is graphite, a form of pure carbon. Graphite is the antithesis of the diamond. Both are made of the exact same atoms, carbon, but they behave in completely opposite ways. In a diamond, the atoms are locked together in a rigid, three-dimensional cage, making it the hardest natural substance. In graphite, the atoms are arranged in flat, thin sheets that stack on top of one another. These sheets are held together by the weakest of bonds. When you press a pencil to paper, those sheets simply slide off one another, leaving a dark trail behind. It is a mineral built for movement. It is soft, slippery, and dark. This same slipperiness makes graphite an excellent lubricant for machines, a quiet grease that keeps metal from grinding against metal. It is a mineral of ease. It does not resist, it yields. There is a relaxation in its nature. It reminds us that strength is not the only virtue. Sometimes, the ability to slide, to move, to let go, is just as valuable. When you hold a pencil, you are holding a piece of the Earth's softest carbon, a stone that flows like water. Staying with the theme of carbon, let us consider the diamond again, but from a different angle. We know it for its hardness and its sparkle. But there is another property of diamond that is soothing to the touch. It is the best conductor of heat of any natural material. This means that if you touch a diamond to your lip or your cheek, it will instantly feel cold. It pulls the heat away from your skin with astonishing speed. This is why, in the past, people would test diamonds by breathing on them. A real diamond would not fog up because the heat from the breath would dissipate instantly. A fake glass diamond would hold the warmth and stay foggy. This coolness is a sign of its incredible order. The atoms are so tightly packed that vibrations, heat, travel through them at super speeds. Imagine a diamond resting against the skin, a cool, soothing weight, drawing away the fever of the day. It is a stone of clarity and coolness, a mineral that refreshes simply by its presence. Let us move now to the mineral apatite. The name comes from the Greek word for deceit, because it often looks like other gems like tourmaline or beryl. But apatite has a much deeper connection to us. It is the primary mineral in our bones and teeth. We think of rocks as something outside of us, something we walk on. But we are walking mineral collections. The calcium phosphate that makes your skeleton hard is a biological version of the mineral apatite. It forms the rigid structure that allows you to stand, to lie down, to rest. When you feel the weight of your body sinking into the mattress, you are feeling the mineral structure of your own bones. It is a profound connection. The mineral world is not just beneath us, it is within us. It is the scaffolding of our existence. Apatite crystals found in nature are often beautiful, green or blue hexagonal prisms, but the microscopic crystals in our bodies are humble and functional. They are constantly being recycled and rebuilt, a silent, ongoing process of maintenance that happens while we sleep. Your body is a construction site of minerals, working quietly in the dark to keep you strong. Consider the mineral sulfur. It is often associated with the smell of rotten eggs or volcanic vents, which might not seem relaxing. But let us look past the smell. Native sulfur, in its pure crystal form, is stunningly beautiful. It forms bright, lemon-yellow crystals that look like shards of captured sunlight. They are transparent and delicate. Sulfur forms in volcanic regions where gases cool and crystallize directly from the vapor. It is a mineral of the atmosphere, born from the breath of the earth. The yellow color is so intense and pure that it glows. Historically, sulfur was used for medicines and fumigants. In the quiet of a mineral collection, a piece of native sulfur is a splash of joy. It reminds us that even in the most volatile environments, the earth produces beauty. The crystals are fragile, soft enough to scratch with a fingernail. They are not meant to last forever, they are meant to be bright. They are a fleeting expression of the earth's internal energy, a flash of yellow in the gray rock. Now let us drift to the ocean. The sea is a vast reservoir of minerals. One of the most soothing connections between the ocean and the land is the formation of oolites. These are not a single mineral, but a texture. Oolites are tiny, round grains of calcium carbonate, usually aragonite or calcite. They look like miniature pearls or fish eggs. They form in warm, shallow seas where the water is saturated with minerals. A tiny grain of sand or shell fragment is tumbled by the waves. As it rolls, layer after layer of mineral precipitates onto it, building a sphere. It is a slow, rhythmic process. The ocean breathes the minerals onto the grain, wrapping it in concentric shells. Over time, these millions of tiny spheres become a rock called oolite limestone. If you were to walk on the beaches of the Bahamas or parts of the Great Salt Lake, you might be walking on these tiny mineral pearls. They represent the gentle side of the ocean, its ability to polish, to round, to smooth. There is no sharp edge in an oolite. Everything is curved and soft. It is a texture that invites touch, a geological memory of the sea's endless rolling. We should also consider the quiet beauty of kyanite. This is a blue silicate mineral that forms under high pressure. It is most famous for its blade-like shape. Kyanite crystals grow in long, thin, flattened columns that look like blue swords or leaves. They often have a striking, sapphire blue color that can be very calming to the eye. What makes kyanite unique is its hardness. If you scratch the crystal lengthwise along the blade, it is relatively soft. But if you scratch it across the width, it is much harder. This anomaly reminds us that minerals have directional personalities. They behave differently depending on how you approach them. Kyanite is often used in the ceramics that make our sinks and bathtubs. It withstands high heat. So, the quiet blue blade in the rock is connected to the white porcelain in your bathroom. It is part of the circuit that allows you to wash away the day. Its blue color is often associated with tranquility. Holding a blade of kyanite is like holding a sliver of the deep ocean or the twilight sky. It is a mineral that cuts through the noise, bringing a sharp, clear peace. Let us turn to the mineral rhodochrosite. Its name means rose-colored. It is a manganese carbonate mineral that comes in shades of pink, from pale rose to deep raspberry. It often forms in wavy bands of pink and white. It looks like a frozen watermelon, or a swirling pink sunset. Rhodochrosite forms in the veins of silver mines, a hidden surprise in the dark tunnels. The Incas believed that the blood of their former rulers turned into the stone, so they called it the Inca Rose. It is a stone of the heart, not in a scientific sense, but in an emotional one. The soft pink color is universally soothing. It is the color of the inside of a shell, the color of a blush. The banding in rhodochrosite tells a story of changing water chemistry. As the mineral-laden water flowed through the crack, the conditions shifted slightly, layer by layer, recording the pulse of the Earth's fluids. It is a mineral diary, written in loops and swirls of pink. Looking at it can lower the stress, a visual lullaby of color. We must also mention spinel. For centuries, spinel was confused with ruby. The famous Black Prince's ruby in the British imperial state crown is actually a spinel. It is a magnesium-aluminum mineral that forms in the same rocks as ruby and sapphire. But spinel is even harder and more durable. It has a high refractive index, meaning it sparkles with a bright, fire-like intensity. However, spinel is less known, a quiet star in the background. It comes in a wealth of colors: red, pink, blue, violet, and black. In recent years, it has gained appreciation for being a stone of clarity. It does not have cleavage, meaning it does not split easily along planes. It is a solid, singular stone. It represents wholeness. When you look at a red spinel, you see a pure, intense color without the subtle zoning often found in other gems. It is a mineral of focus, a bright point in the dark, steady and unbroken. We should also visit the world of the amethyst geode. While we have spoken of quartz, the specific formation of the amethyst geode is worth a moment of quiet contemplation. These are often called cathedrals. They start as giant gas bubbles in basalt lava. Over millions of years, the gas escapes or the bubble collapses, leaving a hollow space. Silica-rich water enters. Iron is present in the water. As the quartz grows, the iron imparts a purple color. The most soothing aspect is the slow accumulation. The crystals grow from the walls inward. The deepest purple is often at the very tips, the youngest part of the crystal. The outside of the geode is often rough, drab rock. But inside, it is a universe of purple crystals. It is a secret garden. Breaking one open is a revelation. It is a moment of discovery that has been waiting for millions of years. The deep purple color is associated with peace, wisdom, and sleep. It is the color of twilight, the transition from day to night. Sleeping near an amethyst, or just imagining its deep violet glow, can help ease the mind into rest. Finally, for this segment, let us consider the mineral that is the ultimate symbol of change and softness: talc. We mentioned it briefly, but let us dwell on its texture. Talc is the definition of softness. On the Mohs scale, it is a 1. It is so soft that you can scratch it with your fingernail. It feels greasy, soapy, and waxy. It is composed of magnesium, silicon, and oxygen, but its structure is made of layers that are barely connected. They slide over each other with almost no friction. We use talc and baby powder to soothe skin. We use it in paint to give it a matte finish. The name soapstone is often used for rocks rich in talc. In the ancient world, people carved soapstone into bowls and cooking pots because it was easy to shape and held heat well. Talc reminds us that not everything in nature is hard and enduring. Some things are meant to be yielding, to be soft, to offer comfort. In a world that values hardness and durability, talc offers a different path. It offers the path of gentleness. It tells us that it is okay to be soft. It is okay to let things slide. It is okay to be smooth. As we come to the end of this fourth part of our journey, think about the duality we have explored. The diamond that cools the skin, the graphite that flows like water, the bones that hold us up, and the talc that is soft as a whisper. The mineral world is not just a collection of rocks. It is a spectrum of textures, temperatures, and colors. It is a world that supports us, cools us, and soothes us. You are part of that world. Your body is made of its elements. As you lie there, feeling the weight of the blankets, remember the graphite that slides, the diamond that cools, and the talc that softens. Let these sensations settle in your mind. The night is deep. The earth is quiet. There is only the gentle hum of the planet, spinning in the dark. We are almost at the end of our journey. But for now, let the quiet close in. Let the thoughts drift like clouds. You are safe. You are comfortable. You are drifting. We have traveled far tonight. We have moved through the deep roots of mountains, the sparkling caves, and the quiet seams of metal and stone. Now, as we approach the end of our journey, let us visit the rarest and most ethereal corners of the mineral kingdom. These are the stones that connect us to the stars, the stones that hold the chemistry of calm, and the stones that remind us of the vast, slow breath of the planet. There is no effort required here. Just a gentle listening, a soft letting go. The night is deep, and the world is asleep. Let us begin this final leg by looking up, even as we go down. There is a group of minerals that are not born of the Earth's own heat, but of the fire of the cosmos. These are tektites, and specifically, moldavite. Moldavite is a biogreen, glass-like stone, but it is not a crystal in the traditional sense. It is formed from terrestrial debris that was ejected during a meteorite impact. Imagine a giant stone from space striking the Earth with such force that the rock beneath it melts and is thrown high into the atmosphere. As it falls back down, it cools rapidly, forming this natural glass. Moldavite is unique because it is linked to a specific impact event that happened in Germany about 15 million years ago. Holding a piece of moldavite is holding a moment of cosmic collision. It is a connection between the Earth and the wider universe. The stone often has a texture like dried mud or ripples, as if the wind froze it in place as it fell. Its green color is fresh and vibrant, the color of new leaves. It reminds us that the Earth is not an isolated island, but a part of a larger cosmic dance. There is something deeply humbling about holding a piece of a star crash in your hand. It puts our small worries into perspective. We are stardust, resting on a blue planet, safe and sound. Next, let us consider a mineral that carries the very essence of relaxation within its chemistry. Lepidolite. This is a member of the mica family, forming in plates and scales, often in shades of soft purple and lilac. But lepidolite is special because it is one of the most abundant sources of lithium on Earth. Lithium is a light, soft metal that is used in batteries, but it is also used in medicine to calm the nervous system. While holding the stone does not dose you with medicine, the knowledge of its composition is soothing. It is a stone that whispers of calm. It is often found in granitic pegmatites, those giant crystal chambers we discussed earlier. Lepidolite has a pearly luster, glowing softly under the light. Its structure is layered, peeling away in thin, flexible sheets. It is a mineral that adapts. It does not hold on to stress, it releases it layer by layer. The color purple, often associated with the crown chakra and spirituality, adds to its mystique. It is a stone of transition, helping the mind move from a state of high energy to a state of rest. In the quiet of the night, Imagine the soft lilac sheets of lapidolite absorbing the static of the day, leaving the mind clear and still. Let us travel in our minds to the Dominican Republic, the home of Larimar. This is a rare variety of pectolite. Its color is an ocean blue, ranging from light sky to deep volcanic blue, often streaked with white patterns that look like waves crashing on a beach. It was only recently discovered in any significant quantity, in the 1970s, though the local people had known of it for years. Larimar is a stone of the sea, yet it is born in the fire of volcanoes. It forms in the cracks of basalt, filling the hollows with its watery blue color. The blue comes from the substitution of copper in the crystal structure. It is a visual lullaby. Looking at Larimar is like looking at the Caribbean Sea on a calm day. It brings the serenity of the water into the solid form. There is no horizon in the stone, only the endless movement of the blue patterns. It reminds us of holidays, of the sound of waves, of the feeling of sand between the toes. It is a vacation for the mind, a mineral postcard from the ocean, telling you to relax, to breathe, to let go. We should also speak of charoite. This is a rare silicate mineral found only in the Sakha Republic in Siberia, Russia. It is found in a specific area near the Chara River. Charoite is instantly recognizable. It is a swirling mass of purple, violet, and white. It looks like a frozen river of silk or velvet. The patterns are complex and flowing, lacking the hard edges of many crystals. It is often described as having a chatoyant, or silky luster, meaning it seems to move under the light. Charoite forms in a process called metasomatism, where fluids chemically alter the rock. It is a mineral of transformation. It takes an ordinary rock and turns it into a masterpiece of purple swirls. The color is deep and royal, yet the texture suggests softness. It is a stone that teaches us to accept change, to flow with the currents of life. To look at charoite is to get lost in its patterns, following the twists and turns of the violet bands until the mind becomes dizzy and then quiet. It is a perfect stone for meditation, a labyrinth of color that leads you deeper into yourself. Let us turn our attention to the mineral sodalite. It is often used as a substitute for lapis lazuli, but it has its own quiet dignity. It is a rich, royal blue stone, often speckled with white calcite. It is a component of the rock lapis lazuli, but when found in large masses, it is sodalite. It is known as a stone of logic and the mind, but in the context of sleep, its value is in its deep blue silence. The blue of sodalite is uniform and grounding. It absorbs light rather than reflecting it. It looks like the night sky without the stars. It is found in nepheline cyanites, a type of intrusive igneous rock. Large deposits exist in Brazil and Canada. The energy of sodalite is described as clearing. It helps to quiet the internal monologue, the constant chatter that keeps us awake. It is a mental break, a stop sign for the racing thoughts. Imagine a dark blue room, quiet and cool. That is the feeling of sodalite. It is a space where thoughts cannot echo, where the mind is finally allowed to be still. Consider the mineral smithsonite. It is a zinc carbonate, often found in the oxidized zones of zinc deposits. It is rarely seen in crystals. Instead, it forms in botryoidal shapes, grape-like clusters. Smithsonite can come in many colors, but the most soothing is a pale, turquoise blue or a soft pink. The surface is often smooth and rounded, looking like clusters of bubbles or dripping wax that has hardened. It feels cool and waxy. The blue variety is particularly calming, resembling the color of a robin's egg. It was named after James Smithson, the founder of the Smithsonian Institution. The botryoidal shape is a geological hug. There are no sharp points, only curves. It is a mineral of containment, holding the shape of the water from which it precipitated. Touching the smooth, rounded surface of smithsonite in your mind's eye is like touching a worry stone, smoothing away the rough edges of the day. We must also appreciate howlite. This is a borate mineral found in evaporite deposits. It is white with gray or black veining, looking like a piece of marble or a spiderweb. Howlite is a stone of supreme calm. It is often dyed to look like turquoise, but in its natural white state, it has a sleepy energy. It is porous and soft. The veining looks like the scribbles of a child, chaotic but contained. Howlite is often used to help with sleep and memory. It is a humble stone, not flashy or bright. It sits quietly, absorbing the excess energy of the room. It is a sponge for stress. The white color represents the blank page, the fresh start. It clears the canvas of the mind, preparing it for sleep. Imagine a white room, empty and silent. That is the space howlite creates. Let us think about iolite. The name comes from the Greek word for violet. It is a beautiful blue-purple stone. But iolite has a fascinating historical secret. It is strongly pleochroic, meaning it shows different colors when viewed from different angles. In one direction, it looks blue. In another, it looks yellow or clear. This property made it valuable to the Vikings. Legend has it that the Vikings used thin slices of iolite as a sunstone to navigate the seas. By looking through the stone and rotating it, they could determine the position of the sun even on an overcast day. Iolite is a compass stone. It helps us find our direction when the sky is gray. It connects us to the ancient mariners who crossed the cold oceans guided by the light filtering through a crystal. It is a stone of vision and guidance. It reminds us that even when we feel lost in the fog, there is a light above the clouds, a constant point of reference that never moves. We should touch upon the mineral prehnite. It is a calcium-aluminum silicate that often forms in botryoidal or stalactitic shapes. Its color is a unique, glowing yellow-green. It often looks like a frozen jelly or a clouded glass. Prehnite is often associated with the heart and with nature. It forms in the vesicles of basalt, filling the bubbles left by gas. It has a calm, nurturing energy. It is not sharp or bright, it is soft and glowing. It looks like the first buds of spring, the color of new life. The name prehnite comes from Colonel Pren, who brought it from the Cape of Good Hope. It is a stone of unconditional love and healing. Imagine a garden of green light, soft and pulsing slowly. That is the vibe of prehnite. It is a mineral that reminds us to be kind to ourselves, to let go of judgment, and to rest in the safety of our own hearts. Finally, let us reflect on the ultimate lesson of the mineral kingdom: permanence and patience. We have looked at diamonds that shine forever, quartz that endures the sands of time, and zircons that are older than the moon. The mineral world operates on a clock that we cannot comprehend. Mountains rise and fall, seas dry up, continents drift, yet the minerals remain, rearranging themselves, patient and eternal. When we worry about tomorrow, we are thinking in seconds and minutes. The minerals think in eons. They are the anchors of reality. They tell us that it is okay to wait. It is okay to grow slowly. It is okay to just be. The pressure that forms a diamond, the heat that forms a ruby, the time it takes to grow a stalactite, these are not struggles. They are just processes. They are the earth doing what it does. And tonight you are doing what you need to do. You are resting. You are part of this slow, beautiful planet. You are made of star stuff and mineral dust. You belong here. You are safe. The rocks beneath you are solid. The night around you is dark. And the silence is a gift. Outro. And so, our journey through the quiet, sparkling world of minerals comes to a close. We have wandered from the deep mantle to the sandy shores, from the humble salt on your table to the glowing gems in the dark. We have seen how patience builds mountains and how light dances with atoms to create color. I hope these facts have settled your mind and smoothed the edges of your thoughts. If you found comfort in this journey and would like to support the Sleepy Facts, please consider liking the video or subscribing to the channel. It helps these quiet stories find their way to other weary travelers in the night. You can also leave a comment below if there is a topic you would like us to explore next time. But for now, the screen can go dark. The phone can be set aside. The world of light and color can fade, leaving only the quiet comfort of the dark. You have learned enough for tonight. It is time to let go. Let the weight of the minerals be your anchor, grounding you, holding you still. Sleep is not something you have to chase. It is something you allow to happen, like water settling in a deep pool. So, close your eyes. Drift on the slow currents of the earth. And have a wonderful, peaceful, and deep good night.